Good afternoon and welcome to you all from Laing O'Rourke Australia's head office in North Sydney. Today we are hosting the MECLA Innovative Building Materials Challenge. We are delighted to have over 300 MECLA members and supporters from across the country participating in this event, both in person and online. I want to begin by acknowledging the Camaragal people of the Eora Nation as the traditional custodians and First Nation people of the land we are meeting on today, and from where we are live streaming. We pay our respects to their ancestors and elders, both past and the present, and we thank them for enriching our nation with their cultural practices. My name is Monica Hannah-Smith, and I am Laing O'Rourke's Sustainability Strategy and Innovation Lead. As many of you know, Laing O'Rourke is a global engineering and construction company. In Australia, we focus on delivering rail and road infrastructure projects, buildings at the transport interface, and infrastructure for the Department of Defence. I sit within the company's Technology and Innovation Group, a global, multidisciplinary team dedicating to accelerating the readiness and adoption of emerging technologies, innovative techniques, and low-carbon materials in construction. This last bit is where I focus. Our company pays special attention to the materials we buy and use in construction because they make up most of our carbon emissions. Over 95% of our emissions are Scope 3, that is, from processes outside of our direct control. And purchased goods such as concrete and steel take the majority of our overall emissions profile. This is, of course, not unique to Laing O'Rourke. It is representative of the emissions profile of the construction industry and the reason why MECLA is so important. And it's not an issue that can be solved in isolation. MECLA brings together stakeholders from across the entire value chain, from suppliers to designers, builders, asset owners and operators, and we work together to tackle the materials and embodied carbon challenge. Construction materials and innovation is an interesting field. The materials we use today are by and large the materials that have been used since antiquity, and their evolution has not been so considerable over the centuries. The most widely used construction material was then and is now concrete, a material made by heating rocks to a very high temperature and those rocks releasing vast amounts of carbon dioxide in that process. But for most of its history, the impact of carbon on climate was not understood. We do the best we can with the information that we have at the time, and when we know better, ideally we do better. And now we know. The link between atmospheric climate and climate change atmospheric carbon and climate change is clear, and so we must do better. And there are areas in which we are doing better, but there is still so much more to do. Our industry and its supply chain have made significant improvements towards lowering the embodied carbon of the materials that we use and the infrastructure that we build. Products such as those being pitched today are going to add to our toolbox. As the host of this MECLA event, Laing O'Rourke aims to help increase industry awareness and understanding of the emerging solutions available to us and to recognise the work in this space as innovation of the utmost importance to achieving our shared sustainability goals. We believe that increasing familiarity of the available alternatives can contribute a great deal to solving other challenges for product uptake, such as existing institutional barriers and the much needed updates to standards and specifications. To the contestants today, thank you for what you do. Your innovative materials, processes and technologies make up the low carbon arsenal we need to tackle climate change. I'm excited to hear about all of your innovative products. I see it's a diverse and exciting lineup, and I'm very keen to hear about the role of these products in our journey to a low carbon future. Best of luck to you all. And so with that, I'd like to hand over to MECLA's Chair, Hudson Worsley.
Thank you, Monica, and thank you very much to Laing O'Rourke for hosting us here. Hello in the room and hello on the Zoom. It's great that MECLA has the ability now to move into hybrid events. As most participants in MECLA will know, we started just before COVID, which freed us from geographical limitations, which was at the time great and continues for us to be national. I'm delighted that New South Wales Government, who gave us seed funding, is now joined by the South Australian Government as a funding body. A big thank you to WWF and Monica Richter at the back, one of our judges, and Climate Kick, two bodies that really make MECLA continue and help us succeed. To all of the organisations whose logos are here, but more than logos, it's the people who come to our meetings and our working groups that do the doing. We talk about MECLA as a do tank. That's because we are about identifying challenges in the journey to reducing embodied carbon. And in doing that, we then have to get on and address the challenge, whether that's understanding definitions and the dictionary of embodied carbon that's been produced. That's the type of doing we do. A lot of what MECLA does is, I guess, theory. It's process, it's practice. We talk about design, we talk about procurement, but the M in MECLA is materials. So today it's very exciting that those in the room can touch, hold, feel, get our hands on the materials that are low embodied solutions for the built environment on which we all work. So I'm very excited that we're here with tangible products, companies that are in the market, products that you can buy, can specify and build with. So this is the embodiment of what MECLA is all about. It's very exciting that we're all here. So thank you for joining us. Question, how has this challenge come about? Well, the idea, several makers, several companies with great ideas and great products have said, well, we're interested in MECLA, but what do we do? How do we get our name out there? So the idea was born. We've all seen Shark Tank and that type of show on TV. So we thought, well, let's do something similar for MECLA. Particularly, Alexi Barnstone, sitting right here, has done so much of the groundwork making this happen. And to get us here, an expression of interest was made available. 21 different organisations completed that expression of interest. Of those 21, 7 are here today to present. And the breadth, the fact that we had 21, I think, is a great indicator of the growth of low emission innovative materials coming into our local market. So those 7 organisations will present shortly. They've been selected, and any of the 21 are worthy. All of the 21 are worthy. But to get to our short list of 7, we've looked at the level of innovation and that the products, it's construction products. It's not a technology, it's a product. Might use technology, but it's a product that can be bought and used. It's in the market now, so Laing O'Rourke can procure it, and others, of course. And there's a range of uses, and we wanted to cover several market segments. So our 7 contestants, our 7 companies, will have 5 minutes to pitch. After that comes a 3-minute set of questions from our judges at the back. And Alexi is keeping time. He'll strictly, very strictly, hold up his 30-second warning sign. That's how strict he is. So keep that in mind, everyone. We need to get through. And yeah, so it'll be fun. It'll be fast. It'll be very interesting to see what comes about. And then our 4 judges at the back, Trevor Folsom, hello, co-founder of Investable. Thank you for being here. Monica Richter, who I mentioned before, my partner in crime in getting MECLA up and running from WWF, also on the board of ASBEC, so she knows a bit or two about building materials. Georgina North from Laing O'Rourke, thank you for hosting us, Georgina. It's wonderful to be here. And Alice Cale, a friend of MECLA, who is now with Investment New South Wales. They are doing all sorts of exciting things, supporting low emission building materials and other investments here in New South Wales to keep us on that trajectory to net zero. Importantly, the winner. So the winner will have access to a booth at Sydney Build in May next year, May 2024, to raise profile of your product, of your material. But being here today is also a great chance to do exactly that. So look forward to hearing what you have to sell, what you have to offer, where it fits in the construction ecosystem. And let's start off with George Reinker from Reynard Wood. George.
Thank you. Firstly, thank you everybody for allowing me to present for this opportunity and this challenge. My name's George Reinke from Reynard Wood, which is a startup company dedicated to circular economy initiatives. Basically, the company collects finite materials from the industrial waste process and manufactures products for the consumer market, where we're focusing through the hardware channels, where these products not only will outlast the longevity of current products, but also once they hit end of life, you will be able to recycle them, much like the same as, much the same as the cementous materials, and perhaps in 50 or 100 years' time, materials again are innovative and different, but you'll be able to use the materials. There is an alliance with the factory offshore, as Australia is the largest producer of iron ore in the world, a third of all production, 80% is going to China, and that's where we're manufacturing at the moment. But there is plans to help Australia enable this locally, because the materials are here in Australia, and to also promote worldwide to keep the offshore China factory busy while Australia ramps up its capability in country. The material opportunity is from an international known standard called high performance fibre reinforced cementous composite, but we're adding in the industrial tailings waste and promoting it towards the consumer market. The binding agent is high grade fly ash that fills in all the gaps and binds it together with the fibrous fast growing grass plants as the fibre, not using any long time-lapse tree fibres at all. Catalyst is a water reducer, reduces the amount of water, and a colorant. So it's very much using waste and fibres that grow fast to create products to ultimately replace timber or hardwood timber sleepers, which is quite large here in Australia, and it's actually taking down a lot of the trees in our environment. Starting off strategically as a single product line to be able to be versatile, and we'll see later how that works. For outdoor purpose, flooring, retaining, fencing, and cladding. Version 1, 2 metres, made to fit inside a container as prototype. We've now passed nearly 4 years, tests, no complaints. Now version 2 with market research and feedback from the builders for the right size. And we're only just doing the testing now in country, but the factory has increased quality and performance to version 1. And version 3 is not yet developed. How we measure the carbon or the benefit with this product is through a life cycle assessment and carbon product declaration and environmental product declaration. Reynard Wood is a early entrant to the market. With the version 2, we can now help retrofit existing built systems, so you don't have to replace the whole system, which helps the environment. But then obviously it's got the waste materials from the industrial tailings, gathering of those materials, limiting other high intensive, not putting any Portland cement, using fly ash, biogenic carbon using grass type plants and other methods. And then the environmental declaration is pretty much a workflow from cradle to grave on how we're actually producing this at the moment. Aussie operations, very low cost, work from home, outsource the logistics. The distribution channel is large, so looking through the independent hardware group channels, potentially maybe in the future with Bunnings, but we're there to start scaling out with the new version. History, so starting out, mixing in a cement truck, bringing it to market, testing it in the markets, being very responsible, working in a landscape outdoor environment, tests the strength of this product. A lot of people will be saying it won't work, and it is. It's not breaking apart, it's maintaining its solid state, and it's looking very positive. So there's another 2,000 planks on the way off the ship to then start restocking. The next challenge will be to keep the flow going and expand from the 20 stores that we've been in the past to reach the 300. Certificate, Australian patent and worldwide patent. The worldwide fits in with the strategy to be global. So the interest to support Australia to enable this capability for consumer products, but then also promote worldwide as an Australian initiative. So showing responsibility in our biggest export of sales and using the making byproducts out of that waste. Goals, pretty much you can see from the multi-purpose plank product with its versatile capability of retaining, flooring, fencing and cladding, how the sales can accelerate. So we've only really been in, firstly, sort of machine gunning out to 20 odd stores throughout New South Wales, but really focusing on a core 1 or 2, which are doing really well. So now just to replicate that one store throughout a whole larger network will be the next challenge. So outsourced warehouse we've got set up for Sydney and Melbourne. Brisbane will come online next year. And then, what would be really ideal is project marketing of these products. Probably Developer Alliance could help that, but ultimately, the more marketing, the biggest barrier is the installer wanting to stick with timber because it's what they're used to, and sometimes they might feel they get a job more quicker. So, in summary, I'd just like to say the best thing or the defence against global warming is recycling, which is what this opportunity is. Thank you. Questions? I was trying to get away from that thing.
From us? Excellent. Thank you so much for that, George. Question from me. How much recycled material, kind of on a percentage basis, goes into like a volume of product?
So currently it's at about 55%, and that could possibly be increased. Ideally, obviously the reduction in use of fibres as we go, or perhaps installing more longer structured bamboo rods that we've had in the past. Maybe that could take up some more volume. But yeah, certainly.
Great.
Thank you. Yes, thank you.
How are you overcoming the strong preference people have for natural wood products, and in your approach and expansion?
I think that's a good question. And where the stores are really selling it well to their customers, because they're really the ones that are enabling it as well, is that the fact that a lot of the products that are timber that we're focusing in on in the landscape area have got dangerous chemicals injected into them, like arsenic and so forth. It's going into the ground. This product has none of that. So unless it's pulverised, the fly ash is not going to come out. But other than that, it doesn't leach. It's very good for the environment and for humans.
And George, where are you getting your waste from, and how much capacity is there to increase that?
So the waste comes from the iron ore, the blast furnace slag, so the ground granulated blast furnace slag, and there's other opportunities around bauxite in the first slag stage as well, which we probably haven't seen here in Australia, but the overseas companies are certainly, particularly China, are very advanced in collecting the waste materials and be able to use them for products.
And are you buying that?
Correct,
waste?
yes. At high volume, so I've got a very good relationship and workings with the factory where negotiating down the amount of materials needed to do a production run. They've got a huge capacity to do more, and they want to do more. And at the moment, we're at a hardwood timber price. We could get down to softwood timber price and sleeper price as we create more volume in sales.
Can I ask what part of the market are you targeting? Which segment?
The consumer, so the DIY or the builders that go to the Mitre 10s and Bunnings to get their materials to build, particularly, under the fence plinths for barriers for fencing, decking and buildings.
Question from me. So you've got a first suite of products. What else could this do beyond the four that you've mentioned?
Yeah, it's a good question. So we really want to focus next on, and the factory's got really good experience in flooring, so it is to target that plastic wood decking market, which is huge. So to get longer and thinner, because a lot of that's not good for the environment. We're cutting it, the plastics are going into the environment when the installer installs it, and they have no solution to recycle the offcuts or what's going to happen in 10, 15 years, because those products won't last as long.
Have you looked at railway sleepers?
I'm kind of little startup, so I know that would be a huge opportunity, and I'd probably need some networking and other ways of getting in to help the materials in that space. Thank you. Here we go.
When's the best time to plant a tree? I mean, most of us know that's 20 years ago. So equally, climate technologies and sustainability technologies, we needed to start 20 years ago as well. We need to do the energy transition. We all know that. Renewables are a big key factor to us, getting to our net zero ambitions. But we know that the supply chains, we know that the built environment, we know that there's a lot of embodied carbon that needs to come forth in products, and this is why we're here. This is why we love MECLA and the initiatives that are being happening. I'm a proud member of MECLA. So MCI Carbon, we're looking at actually taking emissions and stopping them from going up in the atmosphere, transforming those chemically into products and actually making products that can be embedded carbon into the built environment, like concretes and cements. We're making these products with partners like a low emissions or a negative emissions plasterboard with a major global player. We're looking at cement products, and we've got one of our cement products down there. But I'll talk about the journey a little bit, because I think it's important to understand how this and our technology is a technology born out of some inspiration out of Australia with a global view to helping solve climate change. So we're really looking at transforming large-scale CO2 into products. We need to create a whole lot of new products, and we're talking vast amounts when you consider how much cement and steel and other products have been made with high carbon intensity. So we need alternatives, and we think we've got a great solution to that. So the other thing is not relying on carbon prices to develop your products means you've got a competitive edge, and we're very much there. So MCI Carbon, we're very proud that at Glasgow we won #1 climate tech out of 2,700 companies, and I think that was a recognition that our 16-year journey now that's coming to commercialisation is well in train to meet the market and to be able to be exploited globally, but also in New South Wales and in Australia. So what we do simply is we take CO2 and capture it out of a flue gas or take it from a captured process. We react it with low-grade minerals, quarried materials like stuff that's normally just road base, magnesium silicates, calcium silicates. They're just low-grade rock, and we react that, and then it creates carbonates and silicates like magnesium carbonate and calcium carbonate, and these can be used in different formulations, and this is what we do every day. So this is our global reference pilot plant. Our technology came from the Department of Energy back in about 2000. What happened was in 2007, I saw the opportunity that we needed to develop something outside of CCS and everything that the fossils were trying to push us towards. And so we got our team together, we got New South Wales government funding, we got federal government funding, and we had Orica as a large industrial company to join in, and we formed MCI. So MCI's technical headquarters are in Newcastle, and this is what we're running every day with our customers to take feedstocks, CO2 sources, and then make products. Test those products with our customers and with different groups around the world, get the specifications, and then take them to market. So we're building a demonstration plant now. We won $14.6 million 2 years ago from the federal government. We've matched that with our own investor money. We're doing a capital raise right now, and we're basically this will transform 10,000 tonnes of material, which then we're using on large scale with our big industrial customers to do big trials. So we're ready at the end of the next year to start doing big trials with the likes of Laing O'Rourke and others to basically get this into market. We have a massive demand signal from our customers. If we could make 1 million tonnes now, we could sell it. So we're very, very excited. So we've done a whole lot of characterizations of the techno-economics, the validation of the technology, the scaling up of the technology. This is built with chemical engineering expertise out of Orica over the last 10 years. We built it out of their group, and they now joined MCI as the team. So we actually were born out of one of the biggest chemical engineering companies in the world, the biggest explosive manufacturer in the world. So we're looking at slags, serpentinite, oil shale ash, all kinds of nickel tailings with big miners. Any of these are our feedstocks, and we can transform into multiple products. So we built a platform, not just one product. This is a platform technology that can be integrated. So it's like a carbon refinery that would sit next to an emitter that has feedstocks local and has local markets and also international markets. So we've been doing a lot of characterization, testing these products, strength and characterization in market as substitutes or as new products. It's a very big play on our part. We're very well supported by as I say, by our governments now in play around the world. So we've got a whole lot of really top quality expertise, 50 people and growing. We're big in Japan. We've got the Toshu Corporation invested in us and Mizuho Bank this year. We're off there next month, and we've got a whole lot of different customers. We're helping the Japanese decarbonise. So we've got a whole lot of emerging markets, a whole lot of emerging customers. We are a great team. That's what we are. MCI is a fabulous team. We're committed. We're on a mission to put away 1 billion tonnes of CO2 by 2040, and you know we're looking for supporters in that and advocates, and we hope that all of you here today will become our advocates. So we're into a lot of the CRCs as well, doing Hempcrete testing and the like, and we're running fast. This is what a multi-million tonne plant would look like against a 5 million tonne CO2 emitting steelworks, for example, to give you a concept. Thank you.
So Marcus, what are your biggest pain points at the moment to take it to sort of that vast scale of commercialisation?
Funding, absolutely. The biggest barrier to everybody at the moment is there's not the kinds of capital that's required to accelerate our climate ambitions with all the different technologies. So there's just, you know, the financial markets do not have the kind of gearing around risk to actually bring through technologies that need to buy risk and need to accelerate, you know, adopting the risk to get through. So there's a big gap. The classic chasm of death exists for technologies like us that are TRL levels 6 and 7 to get to kind of the next stage. It's a very big challenge, and we need discount rates of 1% rather than 22% for new technologies. And this will come with green bonds and the like, but that's the biggest challenge for everybody right now.
How much carbon are you taking out compared to traditional products on the market?
So it depends on the product, but typically this plasterboard, for example, if we do a substitution against gyprock, and that's what we're doing in assessment with magnesium carbonate, it's it has to have a manufacturing process developed for it, but it would be, this is 50% by weight of captured CO2. So it's a carbon negative material. There's far more carbon in this than the carbon made to produce it. So this is an example of actually getting into products. In cements, for example, we can do multiple substitutions to get the carbon intensity down on cement, for example, down to 300 kilograms per tonne, kind of target ranges, or even further if formulations allow. So different applications, different products. We're doing flooring, we're doing glass, we're doing paper, and in all of those they have different life cycle benefits, but typically we're playing into those and working strongly with the standards bodies and also the manufacturers.
I can see you're across multiple products. Which is the one, you see the biggest opportunity in? And I suppose secondly, who's your biggest competitor? Like, who are you competing against in this market?
So we're competing against business as usual. So there's a lot of pathways. I mean, all the cement groups have all done their pathways of what they, how much intensity they can get rid of. Cement is our biggest, cement and concrete, absolutely. That's where the biggest volume is, because it's such a large market. So we consider that the amorphous silica we're producing and the magnesium carbonate are the biggest. Our latest investor, RHI Magnesita, who is the biggest refractories producer in the world, has invested in us, and we're building our first plant with them in Austria, commercial plant, because they can't get rid of 30% of their emissions because it's in the rock. When they heat the rock up, they release it. We capture it, we produce magnesite, they heat it up, we capture it. So it's actually a circular economy play.
Thank you, Marcus. That was very exciting and a huge scale. Thanks a lot. Tom Watts from XLAM, can I ask you to come up and use the clicker to go through your slides?
Hi everyone. Is that working okay? Yeah, thank you for the opportunity to be here today. It's my first MECLA event, so yeah, really it's a great opportunity, so thank you again for having me. Yeah, I'm really looking forward to the hearing the rest of the presentations, and some great ones so far. So just to introduce myself, better click the button. My name's Tom Watts. I'm a structural engineer working with XLAM. So we're a Victorian-based manufacturer of cross-laminated timber. You may have heard of our business and what we're about. So yeah, we're predominantly a CLT manufacturer. We also combine that with a design and service offering for supplying mass timber projects within Australia and New Zealand. Okay, so basically, one of the common typologies you may have seen in the last few years with mass timber projects is the large sort of post and beam style buildings that you see with this example on the top right. So quite large glulam beams, up to sort of 800 deep, 400 wide, columns maybe 480 by 480, if not bigger. And then the CLT slab spanning between those beams, and they can be quite an efficient structural system, and then you haven't got any secondary beams, and it all works quite nicely, nice and simple. One of the challenges that you do get with that particular system is there's lots of beams that are sticking down quite low into the structural zone. A lot of services need to get across it, and that quite a big coordination exercise. Mechanical ducts tend to be the biggest challenges, they're just due to their size and some inherent limitations and where they can and can't go, that type of thing. You can do some strategies looking at the grid, say putting short spans next to the core to where you can take those ducts and optimise it. But you inevitably end up with some beams that have some quite large penetrations through it, and there's strengthening options for that. But I guess early on in the design stage, you need to know whether that's going to affect, say, 5% of your beams or 75% of your beams. So it's going to have a big cost implication and affect the project overall. So that sort of led us to looking at this product that we developed in-house over a number of years. It's been kicking around for 3-4 years now. And the idea is that essentially it's a lower profile floor system, mimicking the look of a concrete band beam structure, which everyone's probably well familiar with, and some of the advantages of that sort of system. So you're looking at, on the bottom left picture there, you can see a panel that's up to in the range of 240 to 350 deep. They tend to be at the thicker edge of that scale, just for the spanning ability. Up to 1700 wide, and then another panel running crossways over the top, which forms, I guess, the walking surface. That's sort of slab and beam, but think of it as a very wide, relatively shallow beam. It was initially conceived as mainly as an office application for those large commercial ones, but it has had a bit of interest in aged care, residential, and some educational projects as well. Which surprised us initially, but there was a bit of demand there for that. Designed for up to 120 FRL, and we've completed one project with it, and there was definitely some demonstrated savings from a cost perspective, as well as quite a good saving on the design coordination part of it. So I guess, speaking to some of the advantages a bit more. It was a huge, like I said, it was a huge saving on the design coordination exercise. Having everything that inherently runs under the beams means there was really minimal coordination with the services guys. It was services to services coordination, not services to structure coordination, which was very nice for us and the structural engineers. But it doesn't take away the services to service coordination, obviously, but that's one big thing to cross off the list. Having a full CLT floor, it reduces your reliance on multiple suppliers. Getting more of your product from one mass timber supplier has advantages for procurement as well as cost. And the way CLT is produced compared to large-scale glulam, it's easier to get that volume up, and the production procurement timeframes are a little bit better than what you'd see with glulam, so you can align that procurement timeframe a little bit better with the product. Having it all coming from regional Victorian site to the major cities on the east coast is definitely savings on transport compared to imported overseas product as well. So from a sustainability perspective, the CLT band beams, it's just CLT, so it's the product that we've got EPDs established for. We've got the PEFC certification, Declare Red List, all that type of thing. All the feedstock comes within 100 kilometres of the CLT manufacturing facility, so it's all very local in that sense. And I guess a little bit of background to the product itself for those that aren't so familiar with it. It's less than 1% by mass adhesive. The rest is radiata pine, plantation-grown timber, and it also uses the internal layers, the internal lower stress parts of the product are from a lower grade timber, structurally graded timber, but it's lower than the grade that you're using in your framing timber, so it's making use of that potentially not waste product, but lower value product turning it into a higher value product. So to wrap up, this is the availability. It's available now. Like I said, it's just part of our normal CLT production, so it's available at any time. We've done some in-house testing, just looking at different ways of connecting the top and bottom layers. You can connect it in a way that you get some composite action for some further benefit, but you generally don't need to. We've completed a project in Queensland that worked really well. It's occupied. All good feedback on that one. And we've got 2 fire assessments in addition to the AS 1530 Part 4 test to cover all that off. And we've got a data sheet that should say available now. We finished it last week. And we've got some ongoing development planned with the product. Thank you.
Thanks, Tom. Just can you tell us a bit about IP and anything protectable in the design or the makeup, and if not, what's if you win, who are you disrupting? Who's going to lose in your product class?
We also as an opportunity to expand the market. I guess in some ways we're disrupting our own market. We can sell less CLT, but it's potentially replacing some of the glulam components in it, those larger beams. But it can be used in conjunction with glulam beams as well. Like certain parts of the structure you can keep, architects might like to keep the perimeter of the structure with exposed deep glulams for architectural reasons, and all the internal stuff could be the band beam system. So I'd say it's more complementary rather than a direct replacement.
Question from me. Thinking about end of life, is there a recyclability element for XLAM reprocessing? I
guess it's in the same way that the band beam product will be the same as all CLT, where I guess when it's fully within the building and protected from the weather, it's design life of 50 years. So I guess the connections can be designed, I guess, by minimising number of fixings to improve the disassembly part of it, and then I guess potential other products that could be maybe recertification of the timber after the original use, or potentially transformation into lower grade products at another point in the future. But
Tom, can you talk a little bit to what the market segment is that you're targeting, please?
It's predominantly commercial, and then educational and aged care. That's the main products we've seen the application so far in the Australian and New Zealand markets.
And just with any change in building products requires a whole raft of people to get on board. So who do you see your biggest advocate or your biggest challenge in terms of the utilising this new product?
Yeah, I'd say a few years ago there was always that challenge of convincing people to use timber over concrete, or a building would start as concrete and there was sort of an uphill battle to try and convert it to timber, where I'd say that's not so much there. I'd say there's a latent demand for wanting to use the product. And I think the ongoing challenge for us and any mass timber building is fire. And I think there's some of the large compartment issues. There's ongoing research in that. And then, I guess use of exposed timber over a certain height, I'd say, is the main barrier still.
Great. Thank you, Tom. Some lovely looking buildings there. Nice work. All right, so something different now. The Australian Hemp Masonry Company. Clara Marasecki, can I ask you to come up, please? Have the clicker here. Look forward to learning all about your product.
Thank you very much for the opportunity to share a little bit of information about the Australian hemp industry and the business that I've been involved in. My name's Clara Marasecki. I'm the founder and the managing director of the Australian Hemp Masonry Company. And we supply materials and deliver training, and deliver that training by working with builders around the country. So Hempcrete, for anybody who's not familiar with the term, is a generic term for a range of insulative light masonry products made by combining hemp hurd, and you can see that in the illustration on the left-hand side. So it's a woody fibre, which is the inside of the hemp stem. So that's combined with a binder, a lime binder. There are a number of them are available internationally, mostly lime-based, or all lime-based, in fact. And in some companies adds a little bit of sand to that. We do, others don't. So the product is primarily used for non-load bearing walls, and there's an illustration on at the top there. So that's a off-form non-load bearing wall, useful for residential and commercial construction or for retrofits. There's another product which is illustrated at the bottom there, which is a lighter material which we can use for subfloor and roofing insulation. So the products are generally rendered externally, but they can be clad. Internally, they can be used off-form, or they can be clay rendered, or lime rendered, or hemp lime rendered. We supply a hemp lime render. Essentially, it needs to be a breathable render, so it's a breathable system. Our lime binder and our hemp lime render are manufactured in Sydney, and we source the materials regionally in New South Wales. And we've been involved in the hemp industry since 1999. So I began my work with hemp by farming hemp initially prior to commercialisation, then starting work at New South Wales Uni in 2000, worked there till 2006, built that first house out of the hemp that had been grown and processed, and have gone on really to develop partnerships with farmers and with processors all around Australia, so including developing of processing systems or supporting other farmers, so not our business, but supporting other people to develop processing systems. So the first of those in New South Wales, then bought by Tasmania, so we've now got some projects going on down there, but essentially the major component, so just over there underneath the illustration on the left, I've given an approximation of volumes. We're talking about 8 buckets of hemp to 1 bucket of binder and to less than a bucket of sand, and that can be varied depending on the application. But by far the greatest volume in this material is the fibre itself. So it's a very lightly coated material that then is tamped between 2 forms around a structural frame. Why is Hempcrete an innovative building solution? It's probably the combination of performance characteristics, really, and that's what's extraordinary about it, is that it does so many things. So it is a low embodied energy product, mainly because of that massive amount of harvested carbon that's there in every cubic metre of the material. It's a long-term carbon sink, so the oldest hemp building, I think, is in Japan, a National Trust building which is 300 years old. But there's certainly plenty of evidence of durability in buildings that are based on lime. It's a rapidly growing renewable resource, and in that I think it's quite extraordinary. So a hemp crop has a turnaround of about 4 months, and in that period we can produce about 10 to 12 tonnes of dry biomass from 1 hectare, and given that this is a really, really light material, that's an enormous amount of material that can be produced. Assessed as being an environmentally friendly biomass, so no risks to biodiversity. That was looked at very early on in the piece, both overseas and in Australia. Agriculturally useful, so quite extraordinary. To give 2 ends of the story, Belgian Nuclear Research Institute used hemp and flax and assessed how they performed in taking up irradiation from irradiated soils, so effective in that way, used around copper smelters in Poland for cleaning up contaminated land. Within a crop rotation for a farmer will give an increased wheat yield of 10 to 20%, and there are a whole lot of interactions. So a soil remediator or phytoremediator. So really an extraordinary thing in what it potentially could do for carbon farming in Australia. So we could really be harvesting massive amounts of carbon by introducing essentially better agricultural products that are farmed in a better way. Okay, we're doing ongoing research at UTS, looking at structural prefabricated panels. The lived experience on the right-hand side, this is in the 2018 bushfires. Typical of hemp materials is their particularly good thermal performance, so 42 degrees outside, 24 degrees inside, with 250 millimetre thick walls, which is fairly typical. And then the bottom there, acoustic performance is also exceptional. So this was after a house was retrofitted, a renovation and extension in Marrickville. Exceptional performance acoustically under the Sydney flight path. Embodied carbon, so we just going through this quite quickly now, 110 kilos per cubic metre is the estimated. We are reliant on European data. We're working, so both the Australian Industrial Hemp Alliance and the Australian Hemp Council are working on assessing carbon in hemp. But this product really, or my work with this product covers both of those areas, both the farming side of it and the manufacturing side of it. Uptake estimated in Europe as 1.393 carbon equivalent kilos. So that's because of avoided emissions. So we've got this really fast growing crop that is sequestering carbon, it's adding to soil carbon, then we're locking it into buildings, so it's actually forming a carbon sink and keeping that carbon there for a long period of time. So estimates in Europe, and these are based on some fairly significant studies that were funded by the UK government under their renewable housing program. So Journal of Building Materials Science is that if we're locking up at that rate of 110 kilos per cubic metre, the walls of an average size house will use about 50 cubic metres of hempcrete, resulting in 5.5 tonnes being locked up during the building's lifespan. In contrast, a typical new house of comparable size will likely release 48 tonnes of carbon through its walls, equating to a carbon reduction of 53.5 tonnes per house. So obviously in sizable commercial buildings, there is an enormous capacity for locking up carbon in buildings and for having really effective, thermally effective buildings with minimal occupational energy use. Thank you very much. Big picture to explain in 5 minutes.
So in terms of adopting this widely, and you talked about the ability to grow, I think, 10 to 12 tonnes of the biomass. Can you talk about how you would commercialise it, to really build it to scale, and how much land you would need to be able to do that, please?
There are farmers all around Australia waiting for somebody to ring them up and say, okay, plant now. Yep, so that's been in place for some time. That is already operating to quite a degree. So, for example, we've got a project coming up with University of Tasmania. All of that hemp's coming out of Tassie. And they were burning their fibre beforehand, so we grew most of our hemp in Tasmania. We burnt it. That's now been reversed, and that's going into buildings in Tasmania. So there would be no issue whatsoever, but really what we would need is some clear signal. So, for example, for that UTAS project, we know that it's happening now. The hemp grower has already been contacted. Hanson Youngkin, who are the developers there, have actually come forward and said, we're happy to take that off your hands and store it and start paying you for it, which has allowed that processor to have confidence in the process. She doesn't have the storage that's required, so that's actually the involvement of somebody who's making a commitment to building with the material. It will enable that to happen very, very quickly, but the industry is really just waiting for the signal.
Do you see the biggest opportunity in commercial or residential, and which one do you see the biggest challenges?
Do I have to choose between commercial and residential? Because we apply across retrofit and new building. So I think that there are different opportunities because this material can be used and installed by a builder, but you can also train and own a builder to be involved in their own install. There is an amazing, or you can work with communities and train them to install. So it can be applied in multiple ways. There are quite amazing opportunities socially to build with it in the residential sector. If we're trying to lock up massive amounts of carbon really quickly, like Adnams Brewery, for example, in the UK, where they maintain 12 to 13 degrees with the walls and a sebum roof, but no art or the London Science Museum. So there are definitely exemplars out there that are very, very interesting, either because they're dealing with heat or they're dealing with moisture in a building or something else like that specifically. I think that there are opportunities in both of those sectors. Certainly commercial interest would be exciting because of the volume that you could put into a building.
Kiara, who's leading the world in hemp production in your class?
France. Yeah. So yeah, France has been not since the 1980s.
Thank you, Clara. That's a whole industry. Fascinating. All right, our next offering comes from Christopher Standing, MST Bar. I picked it up earlier. Keen to learn more.
Cheers. All right, well, thanks very much for having me. It's good to be back here. You can blame MECLA for letting me in, but it's good to see so many familiar and friendly faces. My name is... Oh, there's a couple more slides. My name is Chris Standing. I'm the Managing Director of Standing Innovative Group. We are the local business partner and distributor of MST Bar, and that's what I'm talking about today. So, I'm not talking about hemp. So unfortunately, I had a great video, but to see a bridge that was completely constructed in Canada with MST Bar. North America is and Canada and the United States, the driving force behind the adoption of glass fibre rebar globally. And in fact, MST Bar is manufactured out of Toronto in Canada. They're the largest pultruder in the world. Our current production rate's about 127 million metres of glass fibre rebar annually. So what is glass fibre rebar? It's engineered reinforced polymer for concrete structures. I'm talking any concrete structure. We're talking about bridges, decks, precast panels, pile cages, you name it. It's been used overseas and we're beginning to use it here in Australia. MST Bar is manufactured in both straight, bent bar, flat work applications in a range of different sizes from 10 mil up to 55 mil and larger depending on the order requirement. And we believe it is the number one solution to concrete reinforcement. Why are we innovative and why is our design, I suppose, harder, better, faster, stronger than steel? It's because it's safer, it's lighter to install, better handling and freight using MST Bar. It's higher performing, it's certainly stronger than steel. And it really comes down for us is we're the premier product globally. Our vinyl ester blend is the best blend globally in the world. We know that. And we use the highest concentration of pure glass, over 90% out of any pultruder globally as well. What does that mean? It means a couple of things really. It means that our performance in a high alkaline environment is second to none. We're talking 14 pH over 3 months in a pressurized environment with no reduction in performance of the bar. Leading industry fire performance over 700 degrees, minimum cover over 3 hours, and retaining the strength of the bar. And as I mentioned, it's the strongest bar in the world at 1400 MPa is the average strength, whereas steel is about 450 tensile strength. The other thing is what sets us apart really from others is the integral rib design. So you can see here, there's a rib design across the bar. That's why we have 3 times better bond strength than steel. And there's no other bar globally that does that and has that design. Some will try, but they can't do that. So in terms of sustainability, we're 4 times less carbon intensive than steel. That's clear. It's a lighter product. So there's huge efficiencies around transport of the product. If I could show you some pictures of trucks, you probably would think it's not from Canada. It'd be somewhere else in the world. But in terms of per cube of concrete, MST Bar, about 20 kilograms versus steel of about 80 kilograms of standard reinforcement, just standard spacing. And what does that mean for recycling? It's already per weight and per volume less than 1%. So in New South Wales alone, you can recycle MST Bar straight with a concrete structure and reuse that as a recycled crushed aggregate mix. So that's a huge benefit. We've completed the LCA and EPD, and we're working through locally for membership with the GBCA and ISC. And the purpose of that is to provide contractors, designers and the like the comfort that we are going through this process and we're meaningfully trying to provide an option around a decarbonised product here in the market. So what's I suppose, all these great things, what's the resistance? Why haven't we seen huge adoption? Well, it's a mindset thing. We're talking about disrupting steel, and they're our biggest competitor is steel. And the biggest barrier to change is the mindset of the people in the room. It's trying to change the mindset towards these early adopters over the side here. And shout out to Fulton Hogan and Seymour White in their adoption and application of MST Bar down in Victoria on MRPV, MRPA and level crossing projects. And that's an example of the retaining wall structure on Pound Road that we used. So what we need is contractors, designers, clients to change your mindset and be like these leaders, be a fast follower, follow them and adopt the product like MST Bar to change how we construct here in Australia. And yeah, that's it for me. So thanks very much.
So just to be clear, so you're manufacturing in Canada and
Toronto.
bringing the product here?
That's correct, yeah. So we ship out from Toronto into Sydney.
What would it take to set up manufacturing facilities locally?
So we need a market reaction, firstly, start adoption of the product. Australia actually has some of the purest glass sand in the world, so there's a huge potential. We want to see the market react here and set up local production in advance of the Brisbane Olympics and be able to be a local supplier for that. So.
And Christopher, I know it's early days, but how are you getting this out to the customers?
So we import by shipping from Toronto, and we distribute from Sydney to
Yeah,
Seven
so I
Hills.
meant more the sales process and your business model.
We direct to business marketing, so we're using our contacts in industry and working with them to find solutions, so B2B marketing.
Can you talk a little bit more about the circular economy piece? You talked about the recycling at the end of its life, but what about within the whole business model itself?
Yeah, so anything specific?
Well, if it's pure glass, how do you create a circular business model out of that particular manufacturing process?
Yeah, so I think to ensure the performance of the product is a pure glass product, we would investigate some recycled glass products, but naturally it's going to bring down the performance of the bar. I don't think the market's ready for that. I think the key thing for us is to present a decarbonised alternative and then be able to present how it is able to meet plus 100 years design requirements rather than what we currently have through a steel reinforced structure, and then present the opportunity around how it can be recycled, as I mentioned, through whether it's temporary works or if there's a change in the structure that we can actually recycle and reuse our product here in Australia.
And how's the cost comparison?
So it's cost comparative, bar to just standard bar. What I didn't mention is if there's any requirement for corrosion protection in a marine environment, and we're talking about galvanised or stainless steel, there's a significant cost benefit. So 3 to 4 times minimum. Cool. Thanks very much.
Thank you, Christopher. All right, next we have House of Bamboo. Jennifer Snyders, where are you? Oh, exciting.
Hi there. Just in case, that's bamboo. Goes with me everywhere. All right. Hi. So, there we go, regenerating our future. So just a little bit about me. I was born into the life of bamboo. My father started House of Bamboo in 1972. I studied architecture and I studied horticulture and the growing of bamboo. And my father became ill in 2011 and asked me to help him out in the business. And so I went and I thought, wow, bamboo. And I have to say, to me, it was just a hippie product, and it was tiki bar and all that sort of stuff. So I thought, well, if I was going to take over this business and invest in it and buy it, I really had to get my mojo around bamboo and just see where it has gone and where it's moved and the manufacturing processes around that. And that's exactly what I did, and I went on this exponential journey, and the more I learned, the more I was committed to using bamboo as a material in our built environment. So bamboo is uniquely positioned as a successful bio-based material and clear comparable material to partner with timber and offer an alternate solution. This is bamboo today. So we've been instrumental in designing materials that can be used as a non-structural material. We get caught in this, is it a structural material? There's all these areas. So I've separated the two applications. It can be widely used as a non-structural material in a multitude of applications. Cladding, decking, flooring, battening, which is very popular at the moment, acoustic panelling, anything that you can think of as a timber product, we can produce now as a bamboo product. I worked really hard around the area of the resins and the glues. We're 99% material bamboo, just under 1% for the resin. And also it was very important to me that I'm a big believer that you borrow from the earth, you utilise the material, and then you return it back. That's the ultimate aim of what we're trying to do. We went and worked really hard with Global Green Tag. We got platinum rated. Everything. We're trying to tick as many boxes as we can to make this as simple as for you to specify this material. And there's your range. Here's your upscaling, structural. Around the world, except for in Australia, we use it as structural material. It's still a developing area. There's still a lot of research that needs to be done around this area, but it is being used as a structural material. We're talking about mass timber construction all the time. We don't have enough supply. The supply is the issue with the timber. We can support this material. There are 1,500 species of bamboo, and each of them have different mechanical properties. So they all have different results. And the better you understand that, the more you start to see it. It is not timber. It will never be timber. It is not to replace timber. It is to partner with timber and help you with the supply issue, because it has properties that are outstanding. And if you use it in conjunction with timber, we're going a long way to the supply issue. It's a no-brainer. But to really understand its benefit, you've got to understand the plant. It's super fast in growing. That's its key, right? Super fast. And as a result of that, it stores up to 4 times more carbon. And in fact, different species even are higher than that. We harvest the bamboo at 5 years for construction material. You can do it less for biochar, you can do it less for a whole range of different products. When you harvest bamboo, you select the culm at 5 years of age out of a forest. You don't actually cut the forest down, you have to physically go in there and pick each culm, piece of bamboo that's 5 years old, and that's why you can see marking on each of those growth issues. So the whole purpose of that is that we retain the forest, we retain biodiversity, and we continue to supply. And after 5 years, if you start a plantation, every year is the year of harvest. Continual supply. And we don't, the root system is a rhizome system, so there's no need to replant. Cut it down, regrows. Cut it down, regrows. It actually dies around about 10 years of age within the culm itself, so it actually says, cut me down, use me, cut me down, use me. Nature gives us the answers. We've got a plant that's doing all of that. Carbon sequestration, carbon embodied, because it grows the faster. Simplistically, I always say the faster it grows, the more carbon it stores, not unlike hemp. When I started understanding the relevance around that, I went, well, why don't we have a bamboo industry in Australia? Every single other country is starting to do it except for Australia, and we have the ability to do it. Started working with the biggest commercial bamboo forests in Queensland, and we've got 250 species growing there. It will resolve the supply, and we can also do economy. From an economy point of view, we can have jobs, and we can grow it, and we can plant it, and we can make things from it, and we can restore our land. So this is it. This is the answer. The plant's telling us an answer. Plant it, harvest it, supply it, manufacture, upscale it. It's the future. We can solve this together. It's an answer. Bamboo!
Jennifer, thanks for that. And let me help you with the rest of your pitch. Tell us about who you're selling to now.
We do both residential and commercial because we've been concentrating on the non-structural bamboo because it's accepted and we got it all tested with the green tag. It's both. So for a lot of fit-outs, well, we don't do enough, of course. A lot of fit-out work in commercial is quite a lot, and then some residential. Yeah, and it works both externally and internally. So we mould treat it for external applications, and it meets the Australian standards. So we've had great results. It's just a matter of the paradigm of what bamboo is, and tiki bar, I believe, is the biggest issue. And as soon as people start to see it, they go, "Oh, is that really bamboo?" So we do both.
Yeah. And is there an industry behind you and around you?
Not really. I think it's individual entities that actually start to do it. There's a little bit of, oh, does this really work? And they try, and then as soon as they do it, we can just expand it. But there's not one industry behind it.
Apologies for my lack of ignorance, but it's not native to Australia, am I right?
There are 3 native bamboos to Australia. So it is native to Australia. And we do have about 250 species growing in this commercial one, so we can see how it works. So really we can grow any of the bamboos, and if we use it for the end purpose of construction, we want to look at the high yield and the cell structure. So we're pretty clear on what we can grow, and they all grow in Australia. So different countries that produce structural bamboo will be based on usually the best growing type of bamboo within that climate. And have its own area.
And is there interest from the rural community to grow it, or is it? I mean, that's a whole education piece there, I assume.
Well, I've been working separately as a separate entity, really working on growing bamboo as a plantation entity in Australia because I see great potential there. There isn't the interest, but these carbon credits that have now occurred really give an opportunity for growers, so they can grow it, get carbon credits, get supported with that process. Every year bamboo plantations need to be maintained, so we can use that for biochar. So it has an answer to all those little aspects, and that commercial plantation's been going for 30 years, and it was planted amongst a whole lot of eucalyptus, and they're all happily, and they're both coexisting and happy, so it sort of has a lot of ticks.
Jennifer, can you talk us through the manufacturing process?
It's not unlike a CLT timber, really. It's very similar. So you basically dry it out. The biggest part of it is probably the heating of it to crystallise the sugar. That would probably be its biggest thing, but it still comes out negative as a result. And we can start to use renewables in that, and again, decreases that.
Thank you, Jennifer. Fantastic, and obviously very passionate about your product. Thank you. All right, our final product is from Brickworks. Kathy Inglis, can I ask you to come up? You're going to throw a brick at me?
Bring my brick. No.
Very good.
You all know what a brick looks like. It's one sitting over there. The humble brick. What's so innovative about the humble brick? Well, these ones they're carbon neutral. Brickworks, we began our carbon decarbonisation journey many years ago. We've been on this path for a long time, and we're very proud that we have had carbon neutral bricks on the market now for 10 years. They're not just carbon neutral, they're actually certified carbon neutral, and we were the first certified carbon neutral brick in the world. So how do we get there? And as I said, this has been a very long journey. It started with our emissions reduction strategies in low carbon technologies. So in our Longford plant, which is in Tasmania, we fire this kiln on waste sawdust, so waste biomass. Our kilns at plant in Sydney at Horsley Park, 2 of those kilns are part fired on landfill gas. And one of those pipelines runs through 20 properties to get the landfill gas from there into our plant. We take all the heat at the end of the kilns and recycle that back into our dryers, so no new heat is used in the dryers. We have done site consolidation and decommissioned some of our oldest plants. Some old kilns are very high energy users, and one of our biggest ways to reduce the amount of energy we have to manufacture bricks is to consolidate our sites and to get rid of the really old kilns. We've increased the brick core percentage, so the holes that are in a brick, we do have solid brick still, but the ones with the holes, we've made those holes bigger. You might think that doesn't do much, but it reduces the amount of clay you use, it reduces the amount of energy to fire them, the amount of fuel to deliver them, so you can fit a few more bricks on every truck, so it reduces the footprint and contributes with the other things. We also put in recycled and waste content back into our bricks. We're investing in the future, and as I said, the easiest way to get your carbon down is to build new plants. Building new brick plants is not a cheap thing. We've just commissioned our brand new plant 22 at Horsley Park, which has cost just over $200 million, if I say that very quickly. This plant has been in planning for years. It's going to be one of the most efficient, highest production plants, so the lowest carbon footprint of a brick, probably anywhere in the world for a brick plant. We're currently working on a feasibility project to look at taking organic waste and fueling this kiln on the waste material generating biomethane from anaerobic digestion from organic waste materials. So we're well down that path, and it's another expensive part of plant to put into it, but it looks like it's going to be a feasible project, and we've just got to get the capital approved by the board. We're also now searching for new sources of biogas, and we've got some hydrogen fuel research going. At the moment, you can't fire bricks with electricity. We can't use renewables to make bricks. We have to use something that burns. So that's why biomass, biofuels, and now looking at hydrogen to do that. We've also got a project going looking at adding organic waste into the bricks and taking organic waste from a landfill site, putting it into the bricks. That also reduces the amount of energy to fire, because as you put it in the brick, it has a calorific value. So that will burn and contribute to the reduction of energy in that plant. All I need is the EPA to give me my licence extension to do that. We've done all the lab work. It's all sitting there waiting for that little bit of permission to do it. Our carbon neutral bricks. So with this, we take and measure everything in Longford, our Tasmanian plant. Everything from the raw materials, the fuel used for vehicles, transport from all our suppliers, all the energy used, all the waste handling, the water usage, packaging, transport to the customer delivered anywhere in the world carbon neutral, and the inherent emissions from burning ceramic materials. So we cover basically cradle to grave, so A1 to A5, plus decommissioning in that cycle. This was NCOS to start with, the National Carbon Offset Program, that's now changed and morphed into Climate Active. So we've had our licence and certification for this, as I said, for 10 years this July, which we're very excited about. In doing this, collecting the data is probably one of the hardest things. And getting the data right, we now look at every part of that process, what energy we use, where the emissions come from, and how we can reduce it. So we break it down also by Scope 1, Scope 2 and Scope 3 emissions, so we can actually get them down as low as possible. Scope 3 is probably one of the hardest to get down, because that's something we can't control. And our biggest component of Scope 3 emissions is the delivery of products to customers. So we do that by offsetting and doing carbon offsetting with offsets to get the carbon neutral. So over the last 10 years, we've abated 73,220 tonnes of carbon. These products are available in the market, used for all sorts of things, but you also get the normal value properties of a brick. They last a long time, they're low maintenance, energy efficient homes, so you have lower operational energy as well. And I just want to say the last thing to finish, that over the last 15, 20 years, Brickworks has reduced an enormous amount of carbon. We're a big energy user and we have quite high carbon emissions. We've reduced our carbon emissions 42% since 2005, and that's a big number. We're continuing our journey, we've got more to do, and that's the carbon neutral brick.
Thanks so much. How does the cost of a brick, your brick, compare to a normal one?
It's exactly the same. There's no additional cost for the carbon offsets that are purchased to offset that last bit. They're exactly the same. It is, I'll just add, if you're taking bricks from Tasmania to somewhere else, you've got a delivery cost of the bricks, but apart from that, they're the same cost.
And following on from that, what impact does that have on your bottom line? How much does a brick cost? And what changes to your margin is that going to impact your business?
It's actually very small in comparison. We now do carbon opt-in because people also want local products. So we now do opt-in carbon neutral from our other 11 brick factories around Australia, and they're opt-in on a project basis, and we then offset those that amount of carbon. It really actually has very low impact, and there's no cost passed on to the customer.
Can you let us know where you buy your offsets from, please?
So we have an offset purchasing policy, and our policy is 30% of the offsets must be Australian. So they're either ACCUs or then we buy some international ones to supplement it. Sadly, Australian ones get hard to source. With Tasmania, we always have some local Tasmanian ones in our mix as well because we want to support the local industry in Tasmania.
One more. Okay. Question, funding-wise, are you guys bootstrapped, family-owned, venture-backed?
We're a public listed company.
Public?
Yeah.
Great.
Yep.
And what percentage at the moment are you selling of these bricks versus of your total?
So carbon neutral bricks would only make up probably 3 or 4% of our total brick market. We're hoping to grow it. That's why we did the opt-in now from the other 11 factories around Australia, and those bricks will increase the volume of carbon neutral bricks on the market.
Why so low, Kathy?
This is a question that's got me for years, and I can't explain it. We got asked, architects used to say, yeah, we get it, bricks are energy efficient, they're durable, you've got all those other properties, but you use a lot of energy to make them. And I went, okay, I can fix that, I'll make carbon neutral bricks. So we went off and did it. Didn't tell the boss when we did it, told him afterwards. And it has not changed the volume of sales at all. So people ask for it, and I can tell you there's a major developer that wanted carbon neutral bricks, doing a whole sustainable project, listed all these things, and they said, oh, but we don't want that brick. We want that brick you bring from Italy. And I went, well, that's not carbon neutral. I can't even tell you what that is because it's our 2% of market that's imported. And they said, oh, well, we don't like those bricks. We want that brick, and wouldn't use a carbon neutral brick. So that's the challenge. There's a wide range. It's not just one brick either. There's a wide range of colours, textures, everything available, but it's down to that choice of the architect.
So other than the judges, we all have a bit of fun now. Thank you very much to our 7 companies. The passion, sticking to time when you're that passionate about your baby, your product, very hard. So thank you very much. Such a range. I don't envy the 4 esteemed people at the back of the room comparing such a range of products. But for us, we've got 20 minutes. We've got drinks and nibbles over to the side. So thank you, Langer Rock, for popping that on. And our very strict timekeeper will yell in 20 minutes precisely for us to come back and hear who the winner is. Thanks, everybody. the judges' room and said that's a bit like comparing apples with grapes. I think it was more like apples with Christmas trees. Just such a range of products. I know the slides are revolving there. Just reminding, we had 21 companies put their products forward. Big thank you to them. All 7 of tonight's companies will have a profile in a brochure that MECLA is developing, and we'll distribute to our 3,000 participants in our community whose emails we sparingly use so that they read what we send when we send it. So thank you very much. I'll do the bottom-up approach. Very strong commendation to MCI tonight. Your scale, your carbon refinery, we love that, and the judges really said top commendation, and really wanting, you know, MECLA members who have procurement responsibilities, design responsibilities, to have you on their, you know, on their wish lists to make it happen. So strongly commended. We look forward to staying in touch with you and seeing your journey. You're also a member of MECLA, so you're not getting off that easy. Tonight's winner receives, I said they have a booth at Sydney Build. This year's Sydney Build had 16,000 visitors. So to have a booth there has a value of $10,000, but think of the market exposure that goes with that. It's really quite an extraordinary gesture from Sydney Build to donate that to MECLA. So thank you very much to Sydney Build for that generosity. Tonight's, we have 2 winners. Australian Hemp Masonry and House of Bamboo will share that booth as, I suppose, members of a regenerative supply chain to the building sector. The biomaterials, that circular industry, a regenerative material, really captures the nature-based solutions that I think are a big part of the answer for the climate challenge that we face. So a big congratulations to Australian Hemp Masonry and House of Bamboo. Thank you. As I've said, it's a bit like watching two of your children playing in a soccer game against each other. You want everybody to win. Doesn't happen, but very strong thank you to all 7 of the companies. We look forward to staying in touch. Not an easy job for our four judges at the back. So a big thank you to Trevor Folsom, Monica Richter, Georgina North and Alice Cale. Not easy. Really appreciate you making the call, going through and having such reasoned arguments. Look forward to having a glass of wine with you shortly. Thank you. Thank you also to Laing O'Rourke for hosting us here tonight. Monica, thank you. It's been terrific to have a fantastic physical venue for an in-person and hybrid online event. Organising all of this, I know, is, you know, it's a discipline in its own. So thank you very much. The generosity of the members of MECLA make MECLA work. So, and this is a great example. So thank you. We have a gift for the judges. I won't hand it out now, but please don't leave without it. Don't tell your dentist about it either, but really appreciate your time contribution this evening. Before you leave tonight, there's a QR code for a Mentimeter. 3 quick questions, just seeking feedback on the event, on MECLA, what you seek to get out of participation in our events. So please scan that and maybe on the way home just go through the simple questions. Keen to hear your feedback. And finally, our next event, we have a spotlight on Scope 3 emissions coming up next week. Different type of event, but a discussion on a topic that is, we heard from a couple of our speakers tonight. Scope 3 is hard, it's out of direct control, we know that by definition, and we'll be diving into that with MECLA members to tear that apart and see what we can learn and what's being done to address the challenges of Scope 3. So, for now, thank you very much. Enjoy some further snacks and drinks here at Laing O'Rourke. Thank you very much.